Welcome to our Big Data Funnel project. Our topic is Goodreads recommendation system. We are Team 10, Nigel, Susie, Jennifer, and Faustin. So first, let's go to the overview. So first, let me introduce the Goodreads to you guys. The Goodreads is one of the biggest book websites that could just provide the free reviews for the readers and also for the book recommendations. The business problem we are trying to solve in this project are three. The one is to create a database for the Goodreads. The second one is to draw insights from the book data and user rating data. And the third one is to build a recommendation system based on the user review by the natural language processing. The analysis tools we are using is S3, Python, PySpark, Hive, and Power BI, and every of them have been connected to each other, including the Power BI. Next is the data ingestion. We use 1.18 GB of Goodreads book database. So there are two kinds of data set. One is about the book, and the second one is about the user rating. So for the book data set, it includes some book fundamental information like the title, author, ISBN, and so on. And for the user rating data set, it contains the three columns with the user ID, book title, and review rating. So in total, there are 30 data sets with 462 columns. For the data ingestion part, so we just provide the overview for the two kinds of data side. The left is book and the right is the user rating. So even you can see like in the left side, the book sample overview seems very consistently, but in our real data sets, so the book data are totally messed up because the different CSV file, they have different columns amount, different cost order, and also even some of them have the different names, and also some of the contents in the CSV file, they are the unstructured and also have a lot of weird symbols in the HTML tag. So the first thing we do for our project is to the data pre-processing. Since what I studied in the later slides, we need to do a lot of work on the data cleaning. So first we do is to remove our comma and the HTML tag. And the second part we do is to remove our meaningless columns like the index in the data frame. And after we doing that, we are trying to merge the tables. But the columns are different. The number are different, names are different. So we just create a standard column index to reorder the columns of each data frames and fill out the none for those latent columns. So after we're doing this, every tables will have the same numbers of columns, and then we can just easy to combine them together. And after the table merging, we do the feature engineering. The first we did is to delete the redundant contents, like the delete, for example, here we did total and one. And the second part we do is to just combine some columns together, like the published date. And the third one we do for feature engineering is to change the data type for the PySpark schema. So our database design is in Hive. So in our Hive database, we have two tables. One is book, and another is user rating. And we also provide the Spark schema for these two tables. So let's now go over to the Faustin to describe the big data transformation.
Okay, welcome to the big data transformation. So this is the whole pipeline from from data storage to data insight. So we first save data in in S3 and then pre-process it using Python, to remove some commas. We also used further pre-processing used PySpark. So in PySpark, we did data cleaning and merging tables, feature engineering, and also format schema, to have the standard schema. And also we generated sentiment score that we're acting as rating, so that we can train the recommendation system. So rating normally range from -1 to from -1 to 1. But because the model it's very efficient to train between 0 to 1, so that you can use the sigma function. So we also standardized sentiment score. We also use the Hive that is connected to Power BI, so that you can generate some insights and just in combination with you. So on the next slide, we explain the design of the recommendation system. So this is the recommendation system. So we use embedding layers so that we can group books with similar content and also user who the same books. And also we just aggregated the output so that they can fit in linear layer, and then we also use sigma in the so that the output can be between 0 and 1. So to generate like recommendation for a particular user, we used like okay like based on the score, we just like ranked like from the highest score like to the lowest score, and then like select like top 10 books.
Okay, so to connect Power BI tool, so first step, we used ODBC data source to add Amazon Excel ODBC driver to Excel file. And for the second step, to connect ODBC to Hive, we input the master node for host and then test the connection. And for our final step, we would get the data for the Power BI and then select ODBC to get the tables. So for the data insights, once we connect to Power BI, we did some visualizations to analyze data set and extract what we can find from the data. So we did modeling to redesign the review ratings, and we broke it down into pre-modeling and post-modeling using 2 tables, books and user data. And we wanted to explore deeper into the type of books that receive the most rating from users, and also how the rating is distributed. So for the type of books that receive the most rating from users, on the top left graph, you can see that Twilight has the most number of ratings, almost more than twice the other books. And we can also look at the author side with the most books in the database in the bottom right of the dashboard. And we can also see the top authors and that most books are of English language. And next we can look at the ratings, and on the bottom left of the distribution of rating is centered around the rating of 4 out of 5. And one other interesting thing to look at is that from the top right graph, we see that there is a high increase on the number of ratings starting from 1980s to around 2008. So, and then it kind of spikes downward. So if we were to do an analysis on that, it'd be interesting to look deeper into that. And for our next slide, this is a visualization of post-modeling data set. And here's what we wanted to look into, the rating scores. So the score toward -1 is really like the book, and then +1 is really like the book, and -1 is dislike the book. So the left graph is the distribution of the rating scores. So you can see that most users are on the spectrum of liking the book. And on the right graph shows all of the users and each of the users likeness of the book. So for our next slide. So what are some analysis we found from the visualizations is that we saw that distributions of ratings are centered around 4. So most of the users seem to like the book that they're reading. And further, we can kind of conclude that roughly 90% of users gave a high score on the likeness of the book, while 10% expressed dislike of the book. So I will hand it over to Nigel now for the next slide.
Thank you, Jennifer. For the challenges part, the first challenge we confronted is the data cleaning part. The book data are totally messed up because here are so many unrecognized symbols, or some symbols that are recognized as the wrong separator for another line when we read the CSV file into the PySpark. And because we have 23 separate files to combine in the PySpark, it is very hard to figure out where the issue comes from. The second challenge we confronted is the inconsistent data schema of the input files. All the input files have different column amount, column orders, column names, and unstructured contents. And the third challenge we confronted is the invisible to training model on the whole cluster. And we figured it out by training model on different nodes on the cluster. And because PySpark is based on the Scala, which is different from Python, so when we train the model in the PySpark, we have to use different packages and learn how to implement them. The last challenge we confronted is the connection between OBDC and visualization tools. And after we conquered all of those challenges, we have 3 business values. So after creating the table to store all relevant information from the book database and analyzing customers' preference and ratings for different books, we can generate personalized content and recommendations for our customers who are in our database. It will save our time to provide better quality suggestions or promotion to our customers, and we can update customers' preference and adapt it to future recommendation. Providing more personalized services and more accurate recommendation will help us gaining more competitiveness and reputation in the market. For our current customer, we can keep higher retention rates with good customer satisfaction rate with more and more accurate recommendations. So this is about our project. Thank you.